This whole class, whether we're doing an experiment in lab or whatever we're doing, you are going to be working lots of word problems. Because like I said, that's real world. Wherever you go to work, if you're in a, well, okay, my husband solves problems too. He works in a bank. He says he doesn't use algebra, but he really does. He just doesn't want to admit it. Anytime you put a formula in a spreadsheet, what are you doing? You're using algebra. I mean, and that's why all his stuff is on Excel spreadsheets. He's like, I don't ever use algebra. Oh, um, my son-in-law is a electrical engineer at an the IP plant down in Pine Hill, so way down south. And his job is to fix stuff. Machine breaks, he's got to fix it. Okay, so when he has a problem, nobody gives him a math formula and says, here, solve this problem. No, his is, that machine's not running the way it's supposed to be running. I got to figure out why, and I got to figure out how to fix it. Okay, so that's problem solving. That works to a point, and then you just got to use your brain. All right. So, all of us are not going to solve problems exactly the same way. We saw with dimensional analysis, there's several different ways you can get to the same end. It doesn't mean that one's right and one's wrong. The same thing here. As long as you are on the right track and you're using the right set of equations and you're making sure your dimensions are consistent, then Carson may work it one way and Adam, you may work it out another, and that doesn't mean y'all need to argue over it because you know what? You both can be right. All right? So here are your steps. Just write down the bold terms. So number one, you got to read the problem carefully. First step, read the problem carefully. It means you might have to read it 2 or 3 times. And reading it is not typing it into the Google search bar. Read it. Okay? Read it. Number 2, and this is going to be something we do a lot that you may not have done in math class very much, but we're going to sketch out the problem. Especially when we start talking about vectors and forces and velocity and acceleration, it's going to be extremely helpful for you to sketch that problem out so that you know and you can visually see, here's what I'm given, here's the directions, here's where, here's what my answer needs to be. Okay, so you need to sketch out the problem. It's going to help you understand what you're given and what you're looking for. Visualize the process is kind of the same thing as sketching, but you want to think about the problem and what's going on and kind of visualize it like a movie reel going on in your head. What's happening? All of those things require you to think. You can't just read it. You've got to be actively thinking about that problem. You can't be multitasking a whole lot. Okay, so everybody got those 3? Read, sketch, visualize. Then strategize. On the strategize part, that basically means, all right, here's what I'm given. Here's what I'm asked to find. What formula or law is going to help me do that? Okay? And you're just going to kind of go through your list of different equations and different laws that may help you find that. Identify appropriate equations and then solve the equation. And there's actually 2 more, I think. You think, oh, well, I solved the equation, I'm done, right? Nope, not quite. It's that thing your math teacher always tells you to do, but very few times do we actually do it. What is that? Check your work. Check your work. Does it make sense? Okay, does it make sense? And in here, are my units working out correctly? Because your units are going to be one of the biggest helps for knowing whether or not you got an answer right or wrong. So you want to make sure those units are dimensionally consistent. You want to make sure all your units have canceled out correctly. And then you want to make sure, is this a reasonable number? Okay, does that make sense? Explore limits in special cases would be the second one. All right. Okay, so we are done with that. Let's look at a couple of examples. How do I get rid of this part? In slideshow display settings. Okay, anyway. All right, so here's a couple of examples. Oh, you can see that. Oh, duh, I'm so dumb. Okay, there we go. All right, so E. coli bacteria is about 0.005 millimeters in length. Convert this length to meters. So this is just a unit multiplier example. So again, our dimensional analysis, we're going to put millimeters on the bottom because that's what we want to get rid of. And we're going to change that. They changed that to scientific notation just because it makes things a little bit easier. For some people, if you don't think it makes it easier, don't put it in scientific notation. It's okay. So we have 5 times 10 to the negative 3, or 0.005, divided by 1,000, and that gives us 5 times 10 to the negative 6. Okay. So any questions on dimensional analysis or unit multipliers? Okay. And I'm not going to spend tons of time on that. If we're good with that. I don't think we need to do that. And that's just more of the same. But remember, you're ultimately going to have to find volume. So you're going to do your unit conversions, which they did over here. And then you're going to multiply all 3 of those. Once you get the units correctly, you'll multiply all 3 of those together to get your volume. Okay, which that shouldn't be too big deal. And we did that yesterday too. Moving on. Okay, so let's take a look at significant figures here. All right, so a tortoise races a rabbit by walking at a constant speed of 2.5 centimeters per second for 52.23 seconds. How much distance does the tortoise cover? Okay, so you need to remember your formula. Or before we even start that, let's practice our strategies. We read the problem, okay? Then we need to try and visualize what's happening. So we got a tortoise and a rabbit. I don't know if you can see, but there's the rabbit. Okay. So we've kind of sketched it out. The tortoise is going 2.51 meters per second. That's one of the things that we're given. We know that. And we know that the tortoise's time is 52.23 seconds. Do we care anything at all about the rabbit? No, we don't. So we're just going to ignore him. Forget that. So what equation should we use? We have speed and we have time, and we're looking for distance. So what equation relates speed and time and distance? Yeah, or it's written in the book as velocity equals distance over time. Okay? Now, so that's our equation we're going to use, but which one of those are we actually looking for? The V, the T, or the D? The D. We're looking for distance. We're looking for distance. Okay? So now we're gonna plug our numbers in. We got 2.51 centimeters per second equals distance over 52.23 seconds. Now, if you like to rearrange your equations before you put your numbers in, that's fine, you can do that. And then put your numbers in last. Or you can plug in the numbers and just solve for the one that's left. So how are we going to get D by itself? Multiply both sides by 52.23. Don't forget your units. Oops. So our seconds cancel out. That cancels out. Distance is equal to whatever 52.23 times 2.51 is how many centimeters? So multiply that on your calculator and tell me what you get. 52.23 times 2.51. Speed. I know it's a V. And I know that's confusing. But it's speed. That's not velocity. How do you know? How do you know that's not velocity? There's no direction there. This says 2.51 centimeters.
So is V always speed?
Mm-hmm.
How would you do that? Velocity.
We'll get to that one later.
Okay, so why would they do that?
I don't know.
Yes. So
just because they want to mess with your head. I don't know. Somebody a long time ago messed up.
Okay, so speed is the time.
It's the distance over time.
Distance over time. Mm-hmm. Length over time.
Length over time.
Oh, I've seen the V everywhere with length over time, but I was thinking that was velocity. But we just learned the definition. Okay, so V, length over time, speed.
Okay, so what is 52.23 times 2.51? 131 point what? 0973 centimeters. So we are confident of that distance out to the 10,000th decimal place? Ew. How many significant figures should my answer have?
3.
Some say 3, some say 2. Justify your answer.
2 plus an estimate, so 3.
How many significant figures does this number have?
4.
4. 52.23 has 4. How many does this number have? 3. So how many should my answer have? 3. 1, 3, 1. 131 centimeters.
A question.
Yeah.
Assuming that you did have 4, do you round that 97 up to a 1? Like, when does rounding work in physics? Ever?
The same way it does in math.
So, like, that's definitely roundable, right?
If you needed four significant figures, you'd look at that 0 and then you'd round it, just like you would any other number. I look at the 9, and that would round up to 1, it'd be 31.1.
Okay, so you can round it.
Yes, math, that's math rules, that's the thing, rounding's rounding. Yep. Okay, so, when you write an answer in physics, it always has to be in the correct number of significant figures. Okay, so don't just give me 31.0973 and don't say, well, I'm going to round it to 2 decimal places because we always say round to 2 decimal places. No, it needs to be correct number of significant figures. Okay, so go back through your rules, and it's just practice. It's just practice. Okay. For multiplying, you pick the least number of significant figures, and that's how many's got to be in your answer. Okay? All right, let's try another example. You and Brittany pick some blackberries. Your flat has a mass of 5.7 kilograms. Brittany's has a mass of 3.25 kilograms. What is the combined mass of the blueberries? So, now, I'm going to have to trust you. Don't read the solution part. Try to figure it out. Okay? So, I can't make it any smaller or bigger, and I can't get rid of that. I wish I could. Wish I could hide it. But, all right, so here's what we got. We got 5.7 kilograms, and we have 3.25 kilograms, and we are looking for the combined mass. What does combined mass mean we're going to do? Add them together, all right? So add them together and give me the correct answer in correct significant figures. Do that on your paper right now. Don't read the solution. Stand in front. So find the combined mass of these two things right here in correct significant figures.
It's 9.0. What? Well, 5.7 plus 3.5, that's 8.95. But
all right, okay. All right, so let's add these. So our first job is we gotta add them together. So that's 5, that's 9, that's 8. 8.95 kilograms, all right? That's not correct significant figures. So how do I figure out what they're gonna be?
It's addition, so you
Addition.
just need the lowest number of decimal places.
Exactly, I need the lowest number of decimal places, which means I'm gonna have how many decimal places? 1. So I need this number and I need 1 decimal place. Well, that's a 9 and the number behind it is a 5, so what's gonna happen? 5 is going to round up to 9, and so that's going to mean it's 9.0 kilograms. Can I drop off that 0 and just say 9? No, I cannot. I have to leave it and have 1 decimal place. Okay? Good? Bad? All right. Okay, so just looking at these numbers, I don't know if you can see them or not. Again, don't worry about the solution. All right, how many significant figures are in that number? 4. 2.00. I have the 2 zeros tell me how accurately I'm measuring that number out to. What about B? 2. What about C? 2. Because I just look at that. That's the beauty of putting things in scientific notation. So just look at the little number in front of the times 10. That's all I gotta do. What about this one? 3.
Okay, so question.
Uh-huh.
Assuming that, I don't know, I forget how to do something, and I have a tiny number, can I just put it in scientific notation and be like, okay, now I know something? Or does that not work?
No, that won't work for you putting it in sig figs. you would have to know your significant figures beforehand.
I mean,
But
I feel like-
if they give you the measurement in sig figs, if they give you the measurement in sig figs, it makes it easy because all you do is look at that number. But you would have to know that this is.
What if it's positive?
Yeah,
You would have to, if you're given that, you would have to know how many significant figures are based on that.
how many is that?
1, 2, 3.
3. So the zeros before are insignificant. and the
They're
zeros
just
after-
placeholders.
Oh,
Doesn't matter.
Then what about
even if there's a
0.05?
decimal before.
0.5 that we-
Because there's a 0 before, in order for zeros to be significant, they have to come after a decimal and after a number. Both,
Okay, right.
okay? They have to come after a number and after a decimal.
And so what if the exponent was positive? Would all those zeros work?
All right, if the exponent was positive, times 10 to the 3, okay, that would mean 2, 1, 0, 0.
Now you have 4.
So you would have to put your line right there. Remember that line we were talking about? The line, if you can't put a decimal in there, the line indicates where the significant figure is. So you'd have to put a line over that first 0.
So it's 3.
So it's 3. It's still 3 because right here, that's 3 digits, right?
Alright.
So you're gotta have 3.
Sounds good.
All right. So what time are we at? We have what, 7 minutes left? No, we have 5 minutes. 7. All right. See. What is homework? Take a picture of it, upload it to school. Yeah. So last night's homework, I gave you homework last night, all right? Make sure you take a picture of it, upload it to Schoology. I'm gonna give you back what you've given me so far, so that you can put it back in your notebook and have it. And I don't have a collection of papers up here.
I need to turn this piano. Okay, I thought I had my shear formations in here. Shoot, you're gonna take me as well. Good work, y'all.
Bro, sitting on the lunch, we need to take a sip of it.
Dude, I was just talking about that.
You know, that's my kind of person right there.
It is.
I'm really wearing.
All right. Okay, so we have about 5 minutes left. You may work on tonight's homework, which is 30 through 38. You can't stand up, no, can't stand up, do that for 5 minutes.
Does it ring at 50 or 55?
Oh, no. It rings at 50, never mind. Well, we still got to stay in our seats. You may, yes, y'all don't have to ask, just make sure they come back.
Okay.
At some point, send them back.
This book is super greasy.
Greasy as in actually greasy, or is that some newfangled term, y'all?
No, it's
Yeah,
like,
it's not
it-
even for
for some reason, it has a picture of a pizza and it smells like.
I got the frame.
Are you teaching a math class?
Yeah, I taught one last year.
What is it?
What math?
Mathematics, modeling mathematics, algebra.
I was gonna take that, but then they said that, that is not
Probably
necessary.
3 of these
You need to take something much harder than
Well, you see, I was gonna just skip
much
that.
harder. No, you need to be bored, stiff, positive, and proper.
I would say half.
So, no, I would pick you out. You try to do that. You need much more of a challenge. All right, y'all have a good day.
For some reason, I just put it in the shower.